In today's lecture, we will implement this research paper, that is analysis of novel metamaterial absorber using equivalent circuit model operating at 3.5 GHz. So this is the geometry and the dimensions are given here. These are the proposed results. This geometry is designed on FR4 substrate and having a thickness of 1.6 mm, and it's a metamaterial absorber, so they use the formula A omega equal to 1 minus S11 mod of S11 square minus mod of S21 square. And because of the value of S21 is 0 in case of absorber, so the A omega can be directly written as 1 minus mod of S11 omega square. And this absorber is resonant at 3.5 gigahertz. So, and this is the proposed electrical equivalent circuit. So we will implement this paper, but we will not spend our time to develop this geometry. So here we have already developed this geometry on HFSS. You can see that there is a dielectric slab of FR4 material and a meander line structure on it and a ground plane at the bottom. Thickness is 1.5 mm and rest of the dimensions are given in the paper. We make this box as an open boundary. Now we will provide the boundary condition. In case of metamaterials, we have to provide the periodic boundary. So today I am showing a different method to assign the boundary. We will select the whole object, then right click, assign boundary, then coupled, and in coupled there are three options. First option, you can provide the lattice pair. Second, you can provide primary and secondary boundary. And third, auto identify lattice pair. So I am clicking on auto identify lattice pair. He is asking the plane. The global plane is XY plane. It is by default. Okay. So in a single click, you will assign the boundaries. So here you can see the orientation of the wave propagation through this material. By press F key, we can switch from object to face mode. So when I am selecting this face, then right click, assign excitation, Floquet Port. Then first he will ask for the direction, new vector. Always keep in mind that when you will assign the Floquet Port, see these axes. Okay. So this is the point, origin of the axis. So you have to choose this point. Then in positive x direction, your first vector will be in the positive x direction, or it can be in positive y direction. Then second vector will be from the origin in positive y direction. Always choose the positive x and positive y direction. Next we are not taking, we are not analyzing the higher modes. So here you can see the orientation of Floquet Port. You are not supposed to choose this point as a origin. Similarly, choose the next surface and right click, assign excitation, Floquet Port. It will show already defined. Next, finish. We have already assigned the setup and swap. So our required frequency is 3.5 GHz. Maximum number of passes 21. In swap, choose interpolating. Then linear count, start frequency 1.7 and frequency 5.25. Number of points are 401. Save fields. When you will see the front view, you will find this kind of visualization. So here you can see that it's an inductive portion. In general, the whole meander line behaves like an inductor. But when we see from the front side, this will visualize like inductor, and there is a gap, so it's a capacitor. So this arrangement is a combination, a series combination of inductor and capacitor, and they form one more capacitor. That on the top there is conducting surface, and at the bottom there is conducting surface, and in between there is a dielectric medium. So again, it's form a parallel capacitor. Now we will implement the circuit on HFSS itself. Just switch on circuit. In this ribbon, you will select the circuit. Okay. Now choose two capacitors, one resistor to compensate the values, and inductor. Now add the port. So this is our circuit. Now in circuit, right click on analysis, add Nexium solution setup, linear network analysis, double click on frequency, start frequency 1 GHz, stop frequency 5 GHz, add. Now again select analysis, right click, analyze. After completing the analysis, right click on results, create a standard report, rectangular plot. We are interested in S1. Now double click on first component R and make it variable by giving the name R1. Same, replace it with C1, C2, and L1. Then go on circuit, design properties. In local variables, choose tuning. We want to tune all these parameters. Now we have to decide the minimum and maximum value. We decide the minimum value of register N and maximum value is 100. Keep the minimum value remain same. We just increase the maximum values. For capacitor, it is 1E and the store minus 10. And for inductor, it is 1E 10 raised to power minus 7. And leave these. Now select Optimetric, right click, tuning, uncheck this box, drag the result. Now in Optimetric, choose tuning and just start to tune these parameters. Uncheck this value. So here you can see that our graph is shifted towards 3.5 GHz frequency and this is less than 10. So now it is well defined curve and all these are the values of inductor and capacitors for which it is resonant at 3.5 GHz frequency. Save these values and all these values will be here. So this is a story of how to make the equivalent circuit of a metamaterial absorber. So in today's lecture we have seen that in HFSS how to provide the boundary to do the analysis of metamaterial absorber, how to insert the formula in output variable to get the curve of absorption and how to draw the equivalent circuit and its values. Thank you.